Hello guys, let's find the derivative of x to the power of x to the power of x and so on. And we're going to be finding it in two ways, but sort of. Because here the two ways, it's not really two different ways, because here at the main point of that is differentiating, it's going to be the same step. So let me just show you what I mean. So for the first step, what you'll have to do is substitute y as x to the power of x to the power of x and so on. So we're trying to find dy by dx. And here for the first method, what you do is you can see we have x to the power of x to the power of x to the power of x and so on. So essentially we have y equals to x to the power of y, because this part right here is x to the power of x to the power of x, which is just y. And right here we have y in the power, and we really don't like exponentials, and it would be better if this was on the floor. But thanks to our friend log, we can take the log natural on both sides, and due to the log property, this y will come down and this will be ln x. And right here, in both of these methods, we have to differentiate from this point and we'll get our answer. So let me just show you the other step. And in the other step as well, we have to first let y equals to this. And now what you do is, instead of letting this as y, we can directly take the log on both sides. So from here we'll have ln y is equal to ln x to the power of x to the power of x and so on. And again, using the log property, this power will come down. So we'll have ln y is equals to x to the power of x to the power of x and so on, ln x. And right here, you can see we have x to the power of x to the power of x and so on. But that is just our y. So we again have ln y as y ln x. So it's just a method to show that this is in fact this. So it's kind of a mini proof to show that this does in fact equals to this, and it can be shown from right here. And let's just do it from here. So we're going to differentiate both sides, but right here we'll have ln y by dx. But using the chain rule, what I can do is differentiate with respect to y. So we'll have 1 by y, and since I differentiated y, it will be dy by dx. So simply using the chain rule. And from here we have to use the product rule. So first we'll have y into the derivative of ln x, which is 1 by x, plus ln x into the derivative of y, which is simply dy by dx. And right here, this is what we're trying to find. And as you can see, we have dy by dx on both sides. So let's just put this to the left hand side. So we'll have dy by dx, and we can take these common. So we'll first have 1 by y, and when this goes there, instead of plus it becomes minus. So we'll have minus ln x equal to y by x. And here let's just isolate this dy by dx. So it'll be dy by dx is equal to y by x by 1 by y minus ln x. And here y by x, well, you can just leave it at that, that's fine. Or what some people do is you multiply y on the numerator and denominator so that you get y squared by x by 1 minus y ln x. But what I'm going to do is substitute y back in as this x to the power of x to the power of x and so on. So for y by x, let's look at what it is. So we'll have x to the power of x to the power of x and so on by x. Now we can use the indices law. If we have x to the power of m by x to the power of n, this will be x to the power of m minus n. Simply this will go up and this will be subtracted. And right here, this x is just 1. So in fact we'll have x to the power of here, x to the power of x to the power of x and so on, minus 1. And if you want to see how, just substitute this as m, you'll have x to the power of m minus 1, and resubstitute m back in, and you'll have this over here. Now for 1 by y, well, 1 by y, we can write it as y to the power of minus 1. And this y right here is x to the power of x to the power of x and so on, multiplied, raised to the power of minus 1. But again using the indices law, here x to the power of n in raised to the power of m, this indices will simply come down and multiply with n. So this will be x into n into m. So right here, this minus 1 will in fact multiply with the power of this base x right here. So this will be x to the power of minus x to the power of x to the power of x, and so on. And just put that right here. So finally dy by dx is equal to here x to the power of x to the power of x, and so on, and here minus 1. So let me just put it like this to make it less confusing. And 1 by y, it's x to the power of minus x to the power of x to the power of x, and so on. And here just minus ln x, and there we go. And this is the clear explanation of my previous video, which is the same thing except I just explained it by speed running it. And here, if you guys done something new, please like and subscribe. Thank you.